he's interested in literature. He loves Shakespeare. And his interest in computer science is sparked when he worked on a women's safety application for the women welfare. And he'd been working towards that. And then he stumbled upon machine learning. So he had made several open source contributions in the field of ML. And he has successful prototypes in an autonomous car, alphabet recognition, cancer classification, chest recognition, using different learning models. And his ambition is to make valuable contribution towards the ML community and leave a message of perseverance and tenacity. So, over to Akshay.
Hey, thanks guys. So, I think first of all it's great to see you guys here because usually on Saturdays you don't see a lot of people on meetups, but I think it's a pleasant surprise. So let me tell you a bit about myself. My name is Akshay. I have worked in machine learning for about 2 years now, and I did some sort of research in specific topics. One of the topics for my research was haptic learning, in which can we do so basically the thought behind of this was to understand whether we can use learning models to get some idea about can we train our models on human features. So let's say we had mouses, right? So for giving input we had mouse keyboards, but then Apple came along and they told me the best input device is our hand. So hence we had the birth of touch screens, right? Similarly, why do we have to use different inputs for our learning model? Can't we use our own different features of our human body, right? So this was my topic, and I did some relevant work in this field. So before I go this, I would like to first of all thank PyData team for having me, because it's actually very difficult to organize something like this and on this grand scale. So thanks to them. And what do I do is I work for Semantic, which is in Kharadi, and I'm working in the data platform team, which is responsible for both big data and analytics. So we are combining big data with machine learning, and we are providing solutions for cybersecurity domain. And I also like to thank them, because without their support, my own personal research wouldn't have been possible. And then I'm also a software innovator for Intel, which means that Intel picks out around 200 people worldwide for this program, and they select people who have some skills in AI or IoT. So if you guys want to apply, do reach out to me. I'll share the links with you. You can apply here as well. And then I'm a Google developer expert for machine learning, and which means that I have basic certifications from Google in TensorFlow. So I have some sort of expertise in that as well. And then these are my contact information. You can reach out to me on my portfolio. This is my website which I have created. We can have a look at it later. And then there's of course my LinkedIn and my GitHub. So if you want to contribute, if you want to reach out to me and talk to me about some contributions, some projects or any help that you require, you can reach out to me on these links, and we can discuss. So before I start anything, right, there's one thing that I always show people, which was my motivation for getting into this field. So this is a story about Tanya and how she overcame her problems and helped Google's machine learning team into developing something new. So let's discuss this after this video. Okay, anyway, so let me explain what exactly is happening. Is she cannot move her fingers or her legs, and she does not have all these tools that we have, right? We don't. Basically, what she does is using her head, she types Morse code and helps her communicate. But this was not easy for her because initially there was less exposure to Morse code, so she had different devices. But if you see that it didn't stop her, she did paragliding and diving as well. And in the meantime, she also helped machine learning community within Google to develop something like this. So if when we'll be going further down her interview, I'll send you the link, of course. You can see that this is a prototype that she created for Morse code using just your I expressions or just right links. So now she was invited for Google. She was invited at Google, where she was discussing the integrating Morse code within the Google keyboard. And this is something that really interests me because no matter what, no matter how sophisticated your problem statement is or how sophisticated your algorithm is, it comes down to only one thing: is that if it could help people or not. And I feel that even with all the disabilities that she had, she was able to overcome all of that and provide back to the community. And this is the video that actually motivated me to make myself more into the research of machine learning, right? So she can, as you can see, that Google actually integrated this Morse code in their Google keyboard, and which will help people like Tanya to make everything everyday things pretty easy for her. Okay, so let's move to a bit of the technical discussions right now. So whenever you start with machine learning, right, there are three things that I would like to talk about, which is AI, machine learning, and deep learning. Okay, so does anybody of you have an idea of what is artificial intelligence, right? So let me tell you what exactly it is, right? So AI means giving intelligence to a computer, right? And there are a couple of ways to do that. However, machine learning only requires you to give data and get outputs from it. So this is I think the most basic or most fundamental way of learning. If you look at yourself, let's say you have to give an exam on history, right? And so what do? You read up the textbooks, right? And then whenever you have the exam, whatever you have read, you try to replicate that, or you try to give an answer on that, right? Similarly, in machine learning as well, we feed data to our system. So we feed all the information required, and then we train a model, and then at the end of the day, we get the predictions. So this is machine learning, feeding data to the machine to generate intelligence. Now what is deep learning or neural networks, right? So one such algorithm of machine learning tries to mimic our human brain. So by mimicking, I mean we have nodes and dendrites. So each of the brain cell has nodes which are different cells, and we have dendrites which connect one cell to another. And similarly, in neural networks, what happens is we have nodes, and each node has a specific function, and then all these nodes connect with each other to have a network, and then we can do all the things that a machine learning model can do. But the most important thing is that the neural network can add some of its own features and learn from them. So I'll discuss that in detail, maybe later. But let's look at some of the examples of what we are doing. So whenever we start with machine learning, I think the most basic or the most fundamental problem statement, like the word count or hello world, is MNIST digit recognition. So let me tell you a bit about how the model looks, right? So this is basically Colab notebook in which you can build your models and work on the cloud. It is free, of course. So yeah, so you can go with it as well. So basically what I'm trying to do is I'm trying to load the data into my X and Y, And let's look at how the data actually feels and looks. So currently I'm trying to get the data from an numpy of 250th length. So I get a label 3, which means that this image looks like 3, right? And then similarly we have 1. And so what I'll do next is, these are some of the pre-processing techniques that I've used, right? So so if you look at the data, right, the pixel intensities range from 0 to 255. So I'm trying to divide it by 255 so that the pixels range from 0 to 1. This technique is called as normalization, and it actually helps you.
Could you please zoom in a bit? Code is not readable.
Okay. Yeah, so this is better now, right? So what I'm trying to do here is I'm trying to divide everything in my training set by 255, which means that my upper and lower range are between 0 and 1. So this technique is called as normalization, in which the range of the entire training set is set between certain values. And this actually helps quite a lot. And not a lot of people do it, but I'll share some details with you of exactly how this helps. Maybe later, but yeah. So this is actually normalization, okay. And then when the Y for the labels, I have converted into one-hot encodings, which means from 0 to 10 or 0 to 9, I will convert it into a vector format, which is pretty basic when it comes to machine learning. So these are some simple changing of shape that I'm doing, just so that my model is able to read it at runtime. And then I'm trying to print some values, which helps me understand what exactly is happening, right? How my training set looks like. So if you look at it, I have 60,000 training examples. I'm testing it on 10,000. And then you can look at the shape. So 28 by 28 means that every image of the digit will have 28 pixels in length and 28 pixels in breadth. And then the range shape is, of course, the value of this range is between 0 to 9, which are 10 digits. So now I have a simple model which just has a forward connected layer. So I'm not using a CNN. I'll recommend CNN whenever we are working with image data. But since this is only, we are trying to find out what exactly happens, I haven't gone with a CNN. So this is a simple network in which the entire data set is loaded into this dense layer, which has around 512 nodes. So right after the output node, we have a 512 node layer, and then after that we have 128 layers, and then at the end I am trying to converge it to 10 classes. So the number of classes is 10. So these 10 classes means the probability between whether the digit is 0 or 1 or 2 and up until 9. So therefore we have gone with 10 classes. So yeah, and then there are a couple of other things that are happening. Some of the activation is ReLU, which is rectified linear unit, which is pretty common when we are trying to learn from a model of this sort. And then important thing is that the loss is categorical cross entropy, which means that the probability should be between 0 to 9, which means that the probability can either be of the digit to be 1, 2, 3, things like that. So yeah, and then I'm using an Adam optimizer, which means that how do I actually try to converge my model. So there are different optimizers that you could use instead of Adam. And then I'm specifically looking at the accuracy of the metrics. And so yeah, so let's look at the model. So this function print summary, it prints how the model looks like. So there are a couple of other ways you can have a pictorial representation as well. But let's look at it this way. So if you see, at the first layer, I have 784 nodes. So these 784 comes from 28 into 28 pixels that we had. And then if you remember, we tried to again add another layer of 512 nodes, just after 784 nodes. And then I have a dropout layer. So dropout layer, what it does is, basically helps the model to learn from all the nodes that are in the network. Okay, so let me give you an example of how this works. So let's say the dataset has these two functionalities or these two features that let's say the crime rate within Chicago is going down from the year 2000 to 2010, and the dataset also has a feature that the average age for entering a beauty pageant is also decreased within the same year from 26 to let's say 18. So although logically there is no relation between these two values, however, if a model is trained on this data, it might develop a correlation that the decrease in the crime rate is directly proportional to the decrease in the average age for entering a beauty pageant in the US, which is of course not true. Therefore, the dropout technique, what it does is it blocks certain nodes within the network, and it forces the network to learn from all the nodes and not just from some of the nodes. So this technique is pretty effective for when you're learning with new networks. Other than that, if you have to, so this is basically called as regularization, in which we don't want the model to learn too much from our training set, but it should be able to generalize well to the entire training, testing and the training data. So similarly, I have other layers, and then at the end of it, if you look at it, I have an output of 10 units, which means my model is going to either predict whether the number is 1, 0, 2, 3, up until 9. And now I'm training the model, and so if you look at it, my accuracy is around 93%, which is pretty accurate. We can definitely go with it. And then I'm also saving the model to PyData.h5 file. So basically what happens is, if you have saved this file, this will contain the weights of every network, of every layer. So whenever you try to predict, you don't have to train again. You just can use the same model and predict it at runtime. And this is the graph for it. This is the accuracy. As you can see, it's increasing as we are going forward, and then the loss is decreasing. Yeah. So, but the important part, so this everybody could do, right? This is a very simple technique. But how can we do something which is different, or which can add value to even this very simple problem? So this is the computer vision part. Let me show you what it actually does first, and then we'll come back to the code. Yeah. So what this does is basically if you look at it, I'm trying to get only the number 4 from the image, and I have tried to draw the same number on paper, and then I'm trying to show it to the computer in the hope that it can recognize it. So there are two things that are working here. First is the computer vision part, in which I'm trying to get the image, segment it, and perform training on it. So if you see on the right, I have the contours block, which is the actual pre-processing that is happening in the back end, where the computer vision is trying to get the image from the paper, and I'm trying to predict that at runtime, right? So this is one of the things that you could do, is that you can draw something on the paper and show it to the computer, and using some pre-processing computer vision techniques, you can get to have a good, have a good application built on top of that. So how we do is, this is very simple. So if anybody has some interest in computer vision, I think it has a lot of scope with machine learning. So what I'm trying to do is, I'm trying to read. So this cap.read, it reads from the webcam, okay? And then I have called this function. So if you look at it, what I'm trying to do is, I'm trying to find a contour. So contour, what it does is, it gets the different contours that are present from the webcam. So let's say if I click an image of the entire hall, the contours will be all the chairs that are all the chairs that are present, and then all the people that are sitting in front of it. But this is also not a very good technique, because you can get a lot of background noise in this technique. But this is something good to start with. And then when I find the contours, I am trying to get the maximum contour, which means that which of course should be the number. And then I'm trying to make predict. So let's say if you look at the predict function, predicts on the model that we have just saved. So if you look at it, the loaded model is loaded using a specific functionality in Keras library, and then I'm trying to predict using the same image, and I'm printing the predictions on screen. So this is one thing that you could do, which I feel is a very good starting point if you want to incorporate both machine learning and computer vision in your work. But then there's also another technique that we could do. How can we feed the data by writing on the screen? And and by writing on the screen, I mean not having a touchpad or a stylus. Can we do something with computer vision and machine learning? So basically, get some using the same technique of finding contours. Can we, draw some kind of a diagram and try to predict it? So if you want to look at the full post, this is the link to it, which you could go through. So this is the code for it, but let's just look what exactly is happening. So yeah, so basically what I'm trying to do is I'm trying to build, I'm trying to draw this image, okay? And so these images are drawn using computer vision, in which I'm trying to segment out only one color from the entire image, and I'm trying to trace out its path, okay? And now if you look, I have trained a model on all these drawings, and then at the runtime I'm trying to predict the same. So mostly if you see, the accuracy is pretty good. And yeah, so this is a fish, which is of course a very bad fish, but it still does the work. Yeah, so this is the application, and this is actually, the data was provided by Google, and this implementation is now a part of Google's official repository. This is called as Quick Draw. If you want to try it out, I think it's very interesting. Let's look at the code. What exactly is happening in the code? So the most important part here is these two lines, okay? So these two lines define the range of the color blue in my, it's the range of the color blue. So these are the RGB values. So if my application finds anything within this range, it is sure that the color of that object has to be blue, okay? And then these are a couple of other initializations. Then if you see, I have loaded the model. So first you have to build a model, and then I've saved it, and then I'm trying to just do predictions on it. So yes, so the most important thing in this is the tracing out of the path, okay? So just to give a gist, what happens is I'm tracing out the path of the blue object, basically drawing its tail, and then using that, whenever the object is removed, I'm trying to send that to the model for predictions. So for that, I'm using a queue. So if you look, this PTS variable is actually a queue. And if you look at this application, I'm trying to, whenever I find the blue color in the image, I'm trying to append that, the center part, the central point, into my queue. And then if the color is still on the screen, that is, I'm still drawing on the screen, then it's going to keep adding it into the queue. Okay, so every point will be the trace of my movement of the blue color within the image. And then when I've removed it, I'm drawing a line on blackboard. So basically I'm trying to draw or trace out the path. And then whenever the object is removed, so this condition will be true, that is, there are no blue object on the screen, I'm trying to send it and get my prediction. So if you look at this function, what it does is it does the same thing. It tries to get the image from the queue stored, and it's trying to send it to the model for predictions. And at the end of the day, if your implementation is correct, you'll get something like this. So I have actually done this for 14 different classes. So for each of the 14 different classes, I was able to predict correctly what the drawing meant. And then you can simply if you want, you can draw, you can display a star like this, or you can even go for maybe just writing a text. Doesn't matter. So basically, the most important thing is you are combining these two different techniques into one, and you are building applications which are maybe one step ahead of what others are building. And then if you want to explore more, there's something else that I did was there's a similar technique that I've used, which I showed you, was to show a piece of paper in which I've drawn the digit. Instead of doing that, we can use similar technique from Quick Draw, and we can draw digits on the screen as well. So this is how it's going to look like. So I'm trying to draw the digit 5, and if you look at these three boxes, this is actually an encoder function. Let's not get into details, but basically it tries to draw the digits, the same digit, from its own memory. Yeah, so if you look at it, this is a more trained network, so it's able to predict a better value for my digit. So you can use these techniques to build a better model, build a better application in general, and which you could maybe showcase later down the line. So now, what in the earlier applications, what we did was, we had an object of a color, and we were trying to draw or maybe get inferences from there. So what if we just use our own features, or what if we just use simple hand gestures or things like that, because that will be much easier, right? Because now we don't have the problems of contours or maybe an object or tracing of the path. That becomes difficult. So this is an application that I developed. It's called as Emojinator, in which I'm trying to predict emojis from my hand gestures. Okay, so if you want to look at the entire the code, you can go to my GitHub. But let's look at what exactly happens in this field. So if everything goes correctly, this is something that you're going to get at the end. So I'm trying to predict all the emojis from my hand gestures, and I think it's doing an okay technique. So for this application, I actually had around 12 different gestures, and I think I have demonstrated each and every one of them. And this technique is actually very fast as compared to other techniques, which are object detection or things, or other more complicated networks. Okay, and so this is the second version in which this is an object detection part, in which I'm not only doing the same thing, but at the same time I'm trying to detect my hand in the entire frame. So for this, the different technique used, which is basically out of the box TensorFlow API, where you specify which object you want to detect, and you have to train accordingly. And yeah, so this is something that you'll. But the important thing is that I use the same data set for both of the applications. So the data set was similar in both of the cases. Okay, so let's look at what exactly is happening. So first of all, this dataset is available on my Google Drive. If you want to try it out, you can download it from this path. And so I download the dataset, and then this is how my model looks like. So here I have gone with a convolutional layer, then a max pooling, then again a convolutional layer, and then max pooling, and then all the regular layers that we have. Okay, so why convolution networks, right? So CNNs, so why they're important is so the CNN has a capability of getting different shapes and colors from the entire image. So whenever we are working with image data, we want to make sure that we have certain mapping towards each shape and each color and each number. So basically so if you look at it, I have used, so this 32 means that I have 32 filters in my model. So, and each filter will be mapped to a specific shape or a feature. So let's say if filter 5 is going to predict only circular objects in my image, then the filter 5 will only predict the circular objects. And then similarly, if the filter 10 is only getting or only recognizing blue color, then the filter 10 will only be recognizing blue color. And this is done out of the box by this API, this API itself. Because in a neural network, if we were using a simple network, we had to specify everything by hand. That I want to detect blue color, I want to detect circular edge. But this is done automatically in a CNN. So this actually helps when we are working with image data. Okay. And then if you look at the graph, the accuracy increases pretty much around, making it around 95-96%, or maybe even more than that, 97%. And then the loss is going down. So basically, the loss is how accurate your model is. Okay. And now this is the important part. So this is where the computer vision parts comes into picture. And there are two things which are important, right? So if we look at the earlier model for this, we had these two lines which were very important. That is, it's trying to detect blue color in the entire image. Okay. And if you look at this line, this does something similar, but it's only trying to detect a skin color in the entire image. And this can be trained, of course, because these are static values for now, but depending on different skin tones, you can actually have a model which gives you the perfect skin tone to detect and to work your model on. Okay, so this is basically does the same thing which we saw earlier. The only difference is we are trying to get all the skin color objects from the screen, which happens with a bitwise AND. So what I'm doing is I'm trying to get AND of the entire image to the blue color, to the skin color, which will only filter out the skin color from the entire image. So it looks very simple, right? It's a very simple mathematical concept of having AND. Okay, but it helps you actually build a model and build an application which is fast, and at the same time it will convey something that you can even use machine learning and computer vision together to develop specific use cases. And then similar things happen is we are finding contours, right? So once we filter out the skin color from the entire image, we get contours from it. So the skin color could be your hand, or even let's say some small object in the background. And as long as the area of your as in the point of interest, which is our hand in this case, contains the maximum area within the screen, is going to predict that. Okay, and then once this happens, I'm trying to predict on the new image that I have just created, and I'm printing out the probability. So after everything goes well, this is what it looks like, and it's pretty fast. If you look at the object detection API, it's slow because it has to do a lot of processing. This doesn't require a lot of processing. This only requires simple AND between the entire image and the skin color. And you can draw or you can use specific applications which are which were already in place, right? So we did play this game which is called as rock paper scissors, in which I think you already know the rules. So I'm just trying to do the same thing using my hand gestures, and I'm playing it against the CPU. So this is just an extension of the project that we just saw. Everything was same. I already trained the model. It was just a matter of interpretation of how we want to go ahead and use this application for. So this is essentially the basis or the background remains the same. So yeah, so this is something. So this is a part of the Imaginator library, the Imaginator project that we have. So if you open it, you will find all these 3 implementations, which are the basic ones, and then going along with the V2, which is the object detection, and then this one as well. So now, so that was only one specific feature, that is, we are only specifying our hands. Can we do something with the face area or the eyes in particular? So this is actually, I think this model or this application has a lot of good use cases. So this is basically, I'm trying to detect whether a person is drowsy or not by looking at their eye aspect ratio, which means how open their eye is, or maybe the area between the different points in the eye. So once this model is, if you look at it, there's a green layer around my eyes, which is actually detecting whether my eye is open or not. So what I'm trying to do here is I'm trying to get this area between my in the eyeballs, and whenever it decreases within a certain time range, I can predict that the person is drowsy or sleeping. So let's say this is actually quite good for people who are in a habit of driving for a really long time. So this can be installed as a simple webcam. You can just install it, and if the person is drowsy, it's going to play an alarm or maybe something like that, and then the person can get some rest, or maybe just have a coffee or something. So this is very simple. So the basis of the entire code is this DAT file, which is a pre-trained model which contains all the facial key points. So this contains around 60 facial key points, which includes your jaw, your nose, your eyes. So I'm just getting all the eyes, all the points within the eye, and I'm trying to get how the area looks like, and if it's going beyond a certain value, I'm trying to predict. I'm not trying to raise an alarm that you look drowsy. But yeah, this application is not going to work if you are wearing sunglasses, because of course then the model will not be able to get the area of your eyes. So another technique that we could use is maybe go for maybe the area between the chin and the neck, because whenever you're drowsy, the chin seems to drop down up until your neck, and the area between them decreases. So that is one application. That is one alternative that we can figure out, but it's up to it's up to more interpretation. There are a couple of other techniques that we could use to develop this application. And then this is, I'm using the same technique that I just saw, but the only difference is I'm trying to convert my the eye movements into dots and dashes. So which is used for OpenCV, right? Which is used for Morse code. So this is basically I'm trying to get. I'm trying to print whether my eyes can be used for dots and dashes and interpret a Morse code language. So if you look at it, I'm trying to blink my eye, and the blink will be, if it's longer than 1.5 or 2 seconds, it's going to count it as a dash, and if it's smaller blink, then it's going to count it as a dot. So the Morse code for H was 4 dots, which I did, and if you see that right now the screen is printing HE. I'm trying to write it for L, and I think the code for L is dot dash dot dot. So if you look at it, after it I get the letter as L. But this is a very limited application because I'm only trying to predict letters. So anybody who has to translate the entire sentence will take a lot of time, right? So yeah, but if this is just an application, you can use this and maybe develop something which is more extensive. So right about now, since we are discussing this face feature that we have, why can't we develop something which can use similar techniques to have a facial recognition model? And by facial recognition, so there's a research paper which is called as FaceNet, which was developed, I think it was developed by Google on Facebook, in which the model talked about one-shot learning, in which you only take one picture and on the basis of that, you are able to predict whether the person is, if it's in your database or not. So let's look at what exactly it does. So this is my brother, and if you look, his name is displayed as Apurv, okay, and the confidence is around 90%, and this is me. My face is able to recognize my face, which is different from my brother, and it's predicting the distance. So this distance is basically how accurate your model is. Okay, we'll discuss the details because you have to get into the details of what exactly this distance means. But you can look at the code. It's already on GitHub. And then I've also added another functionality, is that whenever I'm not looking at the camera, it's not going to recognize me. So let's say if I've closed my eyes, even though the face is still the same, it's not going to recognize. So this is something similar which the Apple has in their iPhone X, in which if you're not looking at the camera, the face unlock will not work. So this is something similar which so basically if you look at the previous model based on the eye detection and eye features, I have just extended that and added that to the facial recognition system to make sure that only recognize me or only recognize any face when the eyes are open. And so it's pretty interesting. If you want to look at the research paper, you can have a look. It's very interesting, and then this is the GitHub link for that. And the distance is basically this line, which means that I'm trying to get the linear distance between so each face will have its own encoding, okay, and this encoding will contain all the distance between different key points in your face. So this will be unique for every person. And then I'm trying to and then I have trained a model on my face, which will have its own distance, right? I mean, which will have its own features. So I'm just trying to predict the difference between these two values, and if it's less than certain value, then this means that the face are almost the same. And then if the distance is less than the minimum distance, right, then I can say that the face belongs to one person. So this is one of the most simplest implementation of facial recognition. But as we go forward, we can have different techniques which are much more robust for this. Okay, and then based on similar things, this is actually called as deep sign, in which I'm working for. This is essentially a sign language recognition system, and I'm currently volunteering at the Center for Research and Development for Deaf and Mute within Pune. It's in FC Road, and I'm trying to learn sign language, Indian Sign Language. And the problem with Indian Sign Language is the fact that it's different within different regions in India. So the sign language in Mumbai is different from the sign language in Pune, because these two communities have different teachers. But what I'm trying to do is, and then we don't have any specific interpretation of if you want to recognize it. So this effort is for if I'm able to recognize, or if I'm able to build something on top of that, and maybe have a universal universal sign language within India. So if you look at it, what I'm trying to do is I'm trying to get my hands and my facial key points. I think all these things are already covered in the previous topics, right? So we are combining all of that, which we have just learned, and I'm trying to predict using all these information what does each sign mean. So it's a bit blurred. Let me just increase the font. So this is actually a sign for the Lord Ganesh, right? So this actually, the hand and the bottom depicts his trunk, and I'm trying to predict the same, although it's very less visible, but this is actually saying that Ganesh. And then in this sign I'm trying to study, which is a simple sign for studying, and I'm able to predict it correctly. And then this is for like, in which I'm placing my hand on my heart and saying that I like a certain thing. And then this is for hi, which is pretty common. And then this sign is for if somebody is feeling scared, then they do this sign. This is specific for Indian Sign Language, and I mean, a lot of work has to be done in this because I'm just trying to predict based on static images. But when it comes to the entire video, then I have to translate information from each frame onto the next frame. And then there's something called as OpenPose, which is a great library. It's by open source by CMU. So it can not only recognize your face and hands, but the entire pose. So if you look at it, it's able to recognize your face, your eyes, your eyebrows, along with the entire pose. So this makes sense because when you're working when you're working and you're trying to infer all the features, why just only stick to face and hands, right? So I tried to use the same model, and you looked at the previous implementation, which was Emojinator, and I'm trying to predict different emojis, and this time I'm trying to use the same library that was open source by CMU, and although it's not looking very clean, but you can detect the entire pose of a person and maybe try to develop your own application. Okay, so this was the my take on how can you use human features for deep learning or machine learning. Okay, and this is already on my GitHub. So if you want to read more or if you want to reach out to me, you can use this notebook which is present this as a starting point, and then build application on top of that. So this was it from my side. If you have any questions, right, reach out to me. You can write to me on LinkedIn or GitHub. I'll be more than happy to help you guys. And this was absolutely great. I think you have been a great audience. Thank you guys.
That was great, Akshay. I mean, your hand gestures and dots and dots gave me an idea of Cold War spy stories when spies used to give signs like this. Okay, so with this, we have a bit of updates. So first update is